Hello, I'm Rebecca Lewington from Cerebras Systems. I'm very pleased to be joined today by two researchers from the Pittsburgh Supercomputing Center. Paola Buitrago leads the Artificial Intelligence and Big Data Group, and Sergiu Sanielevici is the Director of User Support for Scientific Applications. We're here to talk about their work on the Neocortex project, which is a groundbreaking NSF-funded AI supercomputer designed to accelerate AI research in pursuit of science, discovery, and societal good. And Neocortex just happens to feature a pair of Cerebras systems as the main compute element. So my thanks to you both for joining me.
Thank you for having us, Rebecca.
Thank you, Rebecca. It's a pleasure.
So, Paola, for those new to this field, what's the purpose of PSC?
PSC, which stands for the Pittsburgh Supercomputing Center, is a national resource that provides university, government, and industrial researchers with access to several of the most powerful advanced computing systems for high-performance computing. The goal is to advance the state-of-the-art in high-performance computing and offer a flexible and usable environment for solving the largest and most challenging problems in science and engineering research. Okay,
and could you tell us a bit about your background and your role at PSC?
Absolutely. I have academic formation in chemical engineering and systems and computing engineer. I joined the Pittsburgh Supercomputing Center about 5 years ago, and as part of my task, I founded what is the AI and Big Data Group. I contributed with one of the architects of Neocortex to the deployment and the operation of bridges. Then I co-authored what was the proposal for Bridges 2. Also, I am the principal investigator of the project Open Compass, which in turn resulted in the Neocortex kind of vision for the project and then deployment. So Open Compass as such started as a small sort of testbed for AI specialized hardware, or the idea was to answer the question, how does a specific hardware serve specific use cases that are inspired by science, and that laid down the foundations and kind of hypotheses that then resulted in what Neocortex is as of today.
Got it. And Sergiu, same question for you. What's your background and what's your role at PSC?
Yeah, so I'm a computational and theoretical physicist by training. I joined PSC in 1995. Actually, my first assignment was to work with Craig to bring parallel computing into the mainstream using an architecture that was pretty similar to what we're doing with Neocortex today, which is there was something called the Cray T3D, which was an accelerator that provided parallel computing, and we at PSC attached that to a big Cray C90 front end. And that's kind of the same architecture that we now have with Neocortex. But anyway, so parallel computing became mainstream, and then I went on to lead the user support group at PSC, and then also for NSF national programs spanning the various supercomputing centers, the TerraGrid and Exceed programs. And that's basically what I'm still doing now. And I'm helping Paola as the co-principal investigator responsible for user support for Neocortex. And I do the same for Bridges 2.
Right, and for those who don't know, Bridges and Bridges 2 are a pair of, in their own right, enormous supercomputers doing really important work. So Paola, tell us a bit about the purpose of Neocortex. What are you trying to achieve with this system?
Absolutely. So just to clarify, as Sergio mentioned earlier, so I serve as the principal investigator for Neocortex. And so Neocortex is an advanced computing system. It's a supercomputer that is specialized in accelerating extreme deep learning applications and research. It is a 5-year project funded by the National Science Foundation under the program name Advanced Computing Systems and Services, adapting to the rapid evolution of science and engineering. So Neocortex constitutes what we refer to as a category 2 system or an innovative testbed. The goal of Neocortex or the vision of Neocortex is that it is a forward-looking system where novel technologies, architectures, and usage models are deployed, and where new targeted applications, methods, and paradigms for science and engineering discoveries are explored. So in Neocortex in particular, we are featuring two Cerebras servers. They are tightly coupled with an HP Superdome Flex that acts as a front end, but also as the server that helps us with all the data pre-processing and post-processing that takes place around deep learning training and research. And one of the main goals is to expose the national science community to these very promising technologies, and in the process, thoroughly characterize what are the ideal use cases and best practices to leverage and make the most out of these great technologies. We envision Neocortex allowing researchers across the nation to produce what will be the next AI breakthroughs.
Excellent. Now, most of us are used to supercomputers being a very large room full of more or less identical compute nodes. And Sergiu, Neocortex is very different from that, right? Could you tell us a bit more about that?
Yeah, so as Paola said, Neocortex is kind of a specialized testbed system where NSF asked us to explore, to lead the exploration with the scientific community of, where exactly in their workflows something, this very specific architecture or system could do things that no other solution can, including GPUs and things like that. So, but in a sense, I mean, even Bridges 2, which is our production system right now, is heterogeneous in that it has, a variety of nodes and serves a variety of tasks. So we have regular memory nodes, we have GPUs, we have, and we're trying to kind of serve the purposes of workflows that are increasingly heterogeneous and that span various tasks that the researcher might encounter. So we are kind of thinking of Neocortex as also part of a general workflow, and we're trying to explore where exactly it fits in. But the idea of having different kinds of nodes available to researchers, that's basically become our bread and butter over the last few years.
So Paola, what were the kind of applications that drove you towards the design of Neocortex?
Thanks, Rebecca. Yes, so Neocortex was written as a proposal and presented to the NSF. One of the main criteria when they select these proposals is the scientific merit. So how is the system, or how much is the system expected to enable and further scientific progress? In order to have a very high scientific merit, the approach that we took is we went and worked very closely with researchers that were doing genomic research, cancer research, let's say climate prediction, and other type of very ambitious research that was leveraging deep learning. And we worked towards understanding what were the current limitations they were facing, right? Like what was the type of ideas they would explore if they didn't have compute limitations, and how to address those scenarios or applications they would have or they would envision if no compute limitations were there. So all of those applications drove what is the architecture that we propose for Neocortex.
Excellent. And yeah, we touched on this earlier. Neocortex combines a really big shared memory system with a pair of very fast parallel computers that on a single piece of silicon. Sergiu, where did that idea come from? I mean, you touched on it before, that it's some new thinking plus some lessons from the past which have come around again. Could you say some more about that?
Yeah, so Paola can give some more specific illustrations of exactly how it works with or what purpose it serves specifically for the CS1 systems. But the main idea is that it is powerful enough that even very large tasks are, or that data are massaged in such a way that they're always kept yeah, that they always are fed, efficiently to the CS1 units so that they're never starved, so that they can always use, a high percentage, like 100% of the fabric essentially. And also, but, basically it's just a version or a beefed up version of the regular, installation of CS that you have in the Cerebras lab and in other installations where there's like a regular cluster that serves this purpose. But we thought that, having a big, shared memory system with a lot of, and then also efficiently connected to a big storage system, which is provided by Bridges 2, that would be, optimal in that it would really allow large applications to do their data pre-processing and make sure that the unit is fed. And as I said, we have thought of these things before in other contexts as well. So we kind of had maybe that also, was part of what informed the idea of doing it.
Indeed, it's fascinating the way the lessons of the past can influence the future in the way we architect systems. Paola, could you say a bit more about the role of the front end here?
Sure. So the Superdome Flex serves as the front end to the Cerebras servers. The main goal here is to avoid what we refer to as data starvation. That was mentioned by Sergio. So as we all know, deep learning relies on humongous amount of data, and in particular, the type of ambitious research that we are trying to enable. And here we are talking about different levels of or scales of magnitude in terms of data. So it is critical that we feed the servers in a prompt manner such that we don't avoid them, or we avoid them waiting for data, and make the most out of the compute capability that they have. Now, also, we all know that training a model and also doing hyperparameter tuning and whatnot, that takes a lot of compute time, and that's a bottleneck that we are working, or that we want to help researchers with. However, there's also all the pre-processing and post-processing that takes place around deep learning research, for which we also envision the HP Superdome Flex being used, right? So all the data preparation that takes place, and then once you have your trained model, there are a number of tasks that need to be done, like pruning or doing additional kind of validation steps. So that's the vision for the Superdome Flex. Additionally, in later stage of the project, we are looking forward to exploring scaling to more than one server. At this time, we are training on in one server at a time, one Cerebras server at a time. Then one of the open questions that we aim to address through the life of Neocortex is, can we drive the two servers or do a single training job using the two servers? And for that, very powerful high memory, large memory server was needed in order to be able to drive those, the two Cerebras systems at once. Or that's how Envision is work in progress. We expect to share more details on our experiences very soon with everyone.
Excellent. And that's a very good point. There's no point, there's a lot more to AI than just training the AI model. There's no point in having the fastest accelerator in the universe if you can't keep it fed with data. Sergio, you're the first to provide access to Cerebras high performance AI compute to the research community. Why was that important to you?
Well, as Paola said, we are, and Paola's group specifically is spearheading the exploration of how AI can be, how the return on AI, as it were, can be maximized for the research community. And I would say that in addition to the sort of pure, as it were, and applied AI research, which is certainly very important and very much in focus, there's also almost omnipresent now the idea of combining machine learning with traditional simulation in all fields, basically. So for a few years now, PSC has been kind of trying to spearhead the convergence between, shall we say, traditional simulation, traditional HPC, and machine learning, and trying to help the researchers figure out how to combine the two efficiently. So as I guess Cerebras knows well, because that's also what a lot of the national labs are doing. But the use of machine learning where possible to substitute, as it were, for very costly simulation. That's a hugely important area of research right now. And so, we consider it a big part of our mandate from the National Science Foundation, and our our existence as a center, to be at the forefront of letting as many researchers as possible explore these possibilities.
Right, and to do that, you've got to deal with not only this convergence of what used to be very separate fields, but also accommodate a huge range of users and applications, which, so Paola, I assume it's fair to say that flexibility of architecture, but also flexibility of programming is paramount. Would that be fair?
Yeah, absolutely. That aligns with what has been the mission of PSC. We don't focus on a few number of domains, but we just want to enable discovering different science and engineering domains. So in that regard, it's critical that the systems that we offer and the environments that we offer are highly usable. And for that, let's say Cerebras has been a great tool in that normally our users come with their already TensorFlow codes, and running on the Cerebras server tends to be very straightforward, with some special cases when they're doing specialized things, and some workarounds need to be figured out. Now, if I may add, in terms of why is it important to bring a system like Neocortex up and offer Cerebras high performance compute elements? I would like to say that for me, that's Neocortex is a very exciting project in that the way I see it, it democratizes access to very powerful compute to the whole open science national community. So in that regard, then potentially anybody that has the data and the knowledge and the idea can come and use Neocortex to just implement and test their idea, develop it, and potentially produce the next breakthrough in AI or in their domain. So AI is revolutionizing the world, and allowing everybody to come and contribute to that revolution is something that is very important and worthwhile. And we are being able to do that thanks to the Cerebras servers and Neocortex in general.
Excellent. And to that end, on that point, you recently completed your early user program. Can you give us a sense of the breadth of the experiments that you were able to run?
Sure. So the early user program is, it was a 2-month period where we allow access to the system, well, to Neocortex, to a selected group of projects. We had a total of 17 projects that were doing research across different domains. So molecular dynamics, medical imaging, prognosis, a little bit of climate research as well, and genomics. So it's all across the board. And one of the main goals of the early user program was making sure that the system was delivering as envisioned, as designed, and then also work towards better understanding how the users can better benefit from Neocortex. So in that regard, we have interesting results. Users can notice a clear improvement, or an ability to test their ideas and train way faster as expected, and that they continue to advance or leverage the system at this time, and are very satisfied with it.
Oh, excellent. Now that's quite a broad range of applications that were run on the system during that short period. Could you pick a favorite?
I have to say that it's aligned with what I care most, and that's the application of artificial intelligence for just healthcare. So There is one application that uses or leverages multimodal type of data, so images, but also health records and all of that in order to more promptly diagnose respiratory disease, and which, when it's not promptly diagnosed or diagnosed at the correct time, can lead to fatal outcomes very fast. So then having AI at the service of preventing sickness and preventing like fatal outcomes, that is a wonderful use of the system and a wonderful use of AI.
Yes, indeed. So Sergio, with your customer user support hat on, what feedback have you received from researchers about using the Cerebras systems and using Neocortex in general?
Yeah, I think, you know, everybody who had access to the system was very excited about the opportunity. And we did work with them one-to-one. And I have to mention the amazing assistance that we got from Cerebras, specifically from Natalia Vassilieva and her group. And we basically jointly had office hours and you know, did training. Natalia did, you know, some wonderful hands-on training sessions with the users. And you know, while I mean, there is some effort that has to be undertaken by the user, and it's like, you know, it's a revolutionary piece of hardware. Of course, Cerebras makes it as easy as possible to transition, but most people come with, you know, kind of different codes written in other, you know, frameworks, or just conceptually a bit different if they were used on GPUs, for example. So, but everybody had extremely good and kind words about, you know, the quality of the assistance that was provided. So I think everybody is still very excited to use the system.
Excellent. Yeah, there's definitely a virtuous cycle of learning going on here.
Yes.
I'm very happy to be part of it. Paola, you recently closed applications for the next round of projects to run on Neocortex. What kind of proposals have you got?
Oh, we had a very successful call for proposals. We got a total of 53 applications. And once again, they are all across the board. So we are very happy for that because, well, as I mentioned, that's the mission of PSC and also of Neocortex, to support and enable science in all kind of domains, not only what we normally refer to as traditional HPC. So we have applications in, let's say, veterinary, but also on cancer research, genomic research, climate research, molecular dynamics. So it's all across the board. We certainly are very excited to onboard new users very soon and continue making Neocortex available to the community. So yeah, in general, what we are targeting here is, and the selection criteria that we have is, what are the projects that would benefit most and would make more like a better use of the infrastructure. So the challenge is for researchers to kind of come up with ideas that are ambitious enough, such that they would really benefit from the great compute and storage capabilities that we have here.
One thing that I would, or, you know, area that I would actually highlight also is that the technology, wafer scale engine, is, you know, not just for accelerating deep learning algorithms, but it also lends itself very well to accelerating certain traditional HPC applications. And Cerebras, of course, knows this. Natalia has a paper with you know, some folks focused on accelerating fluid dynamics applications. And we got a bunch of these also as part of the responses to this call for proposals. And we are very excited about that, as is Natalia, by the way. So.
Yes, absolutely. Anything with matrices and sparse linear algebra underneath is right in our wheelhouse. Sergiu, when we spoke before, you said something very interesting. You said that the NSF is interested because they don't know a priori what aspects of research, engineering, scholarship, and education this technology will benefit. So when you come to write your final report in 2025, what are you hoping to put in it?
Well, we're hoping to have, of course, success stories by the researchers themselves. So ideally, you know, a large number of publications, well-cited publications that were enabled by Neocortex. That would be really the gold standard. Also, technical accounts of, you know, or describing kind of, these are the kind of applications that, or this is the part of the workflow that, of the scientific workflow that is best enabled by Cerebras systems. So in general, of course, people do all kinds of things on all kinds of systems, but you know, these are the tasks that are uniquely enabled by the system. So probably will write something like that, but you know, maybe with some users or something. But I think as part of the deliverables, I would hope that, you know, we can have something like that, because really that would be what NSF asked us to find out. And so one way or the other, certainly in the final report, but also, like I said, in publications, we would like to highlight that so as to guide the community, you know, further beyond this project.
Excellent. And so, Paola, to finish off, if you were able to build your perfect computer, if you had unlimited resources, what would that computer look like, and what would you do with it? Yes,
certainly. I would like to continue using AI for healthcare, right? Like, or supporting or improving healthcare. Now, it's worth mentioning that the challenge is not only having unlimited compute resources, you also need the right data and the right algorithms. In terms of algorithms, I would continue like making sure these unlimited compute resources I have available support the development of and improvement of algorithms. Let's assume that I have unlimited data, then I could continue putting those at the service of improving just healthcare and health research in general. I think there are some gaps, right? Like having access to a specialized and prompt healthcare resources, like so to have prompt right diagnosis and then identifying the right protocols of treatment and having good prognosis capabilities, that would be fantastic and would have a fantastic impact on the humanity.
Yes, indeed, that's a great answer. And Sergiu, what about you? What would you do with this unlimited computer?
Well, I would just, you know, take over the universe. That's all. If it's truly unlimited, you know, I mean, that's probably the thing to do, isn't it?
Okay, I'm not sure we could actually be in better hands than yours.
I would count on that.
So on that note, let's finish. Thank you very much, both of you,
Thank
for
you.
doing this. It's been quite fascinating, and I wish you the best of luck taking over the universe.
Thank you very much. We look forward to a long and fruitful collaboration with Cerebras.
Absolutely. Thank you, Rebecca. It's been a pleasure.